This is the packet tracer that I want you guys to work on when we do that. And I want to go through and I'm going to try out my instructions to be sure that they work. Here I've got these two guys over here. The wireless NICs should already be configured in these devices. All of them have wired NICs in them. You have to take the old one out, put the new one in. They should be okay. And we looked at this, and these guys already have IP addresses. The thing that we don't have, and we're going to configure for VLANs 10 and VLAN 20. The router on the stick is configured here, and if you can go in and look at it, I've got a challenge at the end of this thing that, go back and see if you can configure a couple of more sub interfaces and add a couple more VLANs to it, and configure SSIDs to VLAN to see if you can add a couple of VLANs to the wireless interface. We did the configuration. This is the one that we did the configuration on here. It's 192.168.1.3. So we have a number of things that are available. We need to first configure trunk ports. This port, the 2 gig ports, the one going to the router on the stick obviously needs to be a trunk. This needs to be a trunk. These are fast Ethernet 01 and 02, I think. Oh yeah, fast Ethernet 01 is right there. So let's go ahead and make them trunk. I'll go back and do the gig just to show you everything has to happen there. Interface config T, interface range fast Ethernet 01 to 2, fast Ethernet 0. We've got to have the start point here, don't we? 01 to 2, and then switch port mode trunk, so that all the ones can get there. Yeah, it's auto, so we have to do switch port encapsulation. Oh yeah, switch port trunk. I didn't read my error message. Switch port trunk encapsulation Q, because this is a label. The other is a layer 3, so we have to configure the encapsulation protocol on it. And now we can do switch port mode trunk. Port mode trunk. So we have the trunk ports configured on these things, and I'd already, I think, done these. Let's see if I've done these. I may not have. New show interface trunk. So fast Ethernet. I don't have the gig ports here, do I? So let's do interface range gig 0, 1 to 2. Let's do an exit, and now do interface range fast or gig 0, gig 01 to 01 to 2, and switch port trunk encapsulation .1Q. We have to configure the encapsulation protocol, switch port mode trunk, to make these trunk ports to allow them to do the communication. The router on the stick, we looked at that earlier. It's got to be, because all of the VLANs are going to go up here to be routed on the sub interfaces. The other ones, because we have the different VLANs, are going to be going from one to the other. We're going to also be doing a couple of VLANs, obviously. So if we do show a VLAN, I don't have anything in here. So now I have to do config T, and I'm going to use VLAN 10 and 20. So I need to create VLAN 10 and VLAN 20. Why do I need to do that? Because if I did the interface trunk up here, the only VLANs that are allowed is 1, because it's the only one that existed then. And now if I do a show interface trunk, 10 and 20 are allowed and active in the management domain. So they can now get into the trunk. We can send the traffic back and forth on them. If they're not configured on this switch, it's not going to work at all for these things. So we're going to create these things, configure the trunk ports. We did that. Now we're going to add the SSIDs and associate them with VLANs. And we're going to do that on our wireless LAN controller. I'd already logged into this thing a little earlier, and this is the login. The devices themselves, when we hook up, and you're going to have to hook these up, when we connect them, these become PoE, power over Ethernet connections. They'll automatically be turned on when you connect them. Or you can go in and plug in the power supplies if you want. Either way will work. So what we're going to do is go over here, say on the top interface from the menu, select the controller link. So we'll go to the controller here, And in the controller, we're going to go to the interfaces. And so on the interfaces, we're going to go over here. It doesn't show up. We're going to do a new interface to configure here. And I'm just going to call these things VLAN 10 and VLAN 20 so that I don't mess them up. VLAN 10, and we'll call this, the VLAN ID will be 10. And we'll apply this VLAN 10 so we have some information, the physical port number, the physical port information, and the physical port is what we're connecting to, and I think it's gig 1. So the physical port we're connected to is port 1. There is no port. The physical port is port 1. When we do that, the VLAN identifier is 10. The IP address that we're going to use, 192.168.1, and this is the virtual interface, the one that faces the users. We did 1.2 as the computer. Well, this one won't. No, this one will be 192.168.20.2. We can use 20.2. The mask 255.255. Well, let's go back and do this one right, because we're VLAN 10. So let's guess we probably should use it. 255.255.255.0. The default gateway, the virtual interfaces, the sub interfaces are already the 1 addresses. So 192.168.10.1 is going to be the default gateway. Access control list, none of this. DHCP server, we don't really have to set that. That is something that we can do, but I don't think we need to do that right now for this one. So let's apply this and see if it works. It says that it's going to shut it down for a little bit. Let's go back. And we have this one configured. The interface, a virtual interface. The VLAN, okay, VLAN, the interface name, the virtual down here is the one that we didn't do anything with. The VLAN 10, VLAN identifier, the address of the interface, dynamic interface, AP management is disabled on this thing, and that's kind of where we want all this to be. Let's go now to VLAN 20. It's going to be really bad if it doesn't work. VLAN 20, and the VLAN ID will be 20. Apply it, and go through the same process here, and it was interface 1. VLAN 20, the IP address 192.168.20.2, and the mask is 255.255.255.0. The gateway 192.168.20.1. And now we can apply that one, and we should now have our 2 interfaces. Now we're going to associate the interfaces with the wireless LAN. So we're going to go in here and we're going to create a new, we're going to say go. And when we do that, the profile name WLAN, and I'm going to do the same thing here. We'll do VLAN 10, and the SSID we can call, let's call it VLAN 10. Here's 2, we're going to apply it. And there's a couple little things that typically get me. Let me do it first. We're going to enable it. And then we go down here, which VLAN are we going to associate it with? We're going to associate it with VLAN 10, and I messed that up, VLAN 20. I mean, I don't know why I keep the 10. It's the SSID, VLAN 10, VLAN 10. That's to keep me straight, and you can see why we're going to do this. Security, let's go in here and do WPA2 for this thing. Let's do a WPA pre-shared key. And for VLAN 10, let's call it password 10 when we do it. So that should allow that to happen. One of the other things that you're going to have to do before this is going to work is go over here to advanced and come down to Flex Connect. Otherwise, it just won't work. It'll only have a single VLAN. Everything will get IP addresses on the management VLAN unless we configure that. So let's try apply on this and see if it made my changes. It did. We have the VLAN 10 here. Let's go back and do one other one here. VLAN 10, a wireless LAN. Let's create a new one. Let's do VLAN 20, the SSID, and 20. Apply that. When we do this, we go through the same process. Enable it. I did this one day, didn't enable it. I'll tell you, nothing works very well. Now we'll go down and we're associating the SSID, and I realize the SSID is VLAN 20. It could be whatever we wanted it to be with that VLAN. Security, let's go do the same thing except that WPA2, we did both of them WPA2, pre-shared key. Let's make this one capital password and go over here to advanced, and we still got to go down here and enable the Flex Connect. After that, now then we should be able to go to these guys over here, and let's see, go to the desktop. They do have wireless NICs in them. Go to the wireless PC, connect, and see if they will show up. Hopefully, and they do. VLAN 10, VLAN 20. Let's connect this guy to VLAN 10. We'll connect WPA2 personal. It was capital PASSWORD 10. Connect. See if we got connected. You can tell by the lines we're connected to it. The other thing that I like to do is to do an IP config, and we actually got an address on the 10 network. So we're on the 10 VLAN by going through those processes. Let's go down to this one. Let's do similar here configuration. We'll go and do a connect and wait and see if we get the connections here. Here we go. Let's put this guy on VLAN 20 and let's connect, and we made it capital password 20 was the pre-shared key, and let's see if yep, we're connected. Let's see if we got an IP address on the correct network. IP config, we're on the 20 network to do these things. And I started them at 21. I think I did the first 20 were reserved addresses for these things. Is the router working? Let's see if we can ping 192.168.10.1, and we can do that. Yeah, let's see if I'm just going to make a guess that the other guy is 10.21 also. It may or may not be 10.21, and that may not be the case. We'll see here, timed out. So yeah, now we're going from one network to the other. It means our router on the stick is working. Our wireless networks are working. Our wireless LAN controller is working. Our lightweight access points are working. And we've got these guys out here on their separate VLAN so that we can either allow them to communicate, and we can go to the router and create access control lists and restrict what kind of access one network has to the other if we want to do that. But they can each now get to their own resources VLAN using their own SSIDs. So that is the step-by-step how you configure that thing. When you open the PKA file for that wireless LAN controller and packet tracer, you're going to get this set of instructions. I said I was trying them out, and they actually looks like they actually do work. There's a challenge down here to create some sub interfaces. We looked at that, and all you got to do is look at what is in there in the shell, go back and basically emulate, simulate, do the same thing over again for those things. See if you can get some other networks on there. So to configure these things, to configure the wireless LAN, we have the WLAN and the VLANs going through the CAP/WAP from the AP, from the access point to the wireless LAN controller. Switch is going to allow us to configure these things. The VLANs here from the wireless LAN controller. CAP/WAP, remember we've got one for data and one for management. The management is going to be encrypted by default. The data won't. So we have the interfaces here that we went through the process. And again, the reason I'd like for you to do these is so you go through the process. And it's like, okay, I'm going to create the interfaces, and now I'm going to associate. The interfaces will be the VLANs. So now I'm going to, and we put them on the VLANs. Now we associate the SSID with the VLAN that we just created to put those particular SSIDs on them. The admin users, this is a different wireless LAN controller that shows up, and then it shows up as the images in the books. But when we get to these things, configure WLAN creation, this actually the wireless LAN controller. The configure the wireless LAN controller, configure the lightweight access points, register the lightweight access points to the wireless LAN controllers. The registration is going to happen automatically. That's because they're configured to do that. They have their own authentication certificate built in that Cisco put into the devices that they then authenticate to the wireless LAN controller. We saw that earlier when we were looking at, oh yeah, they already have an IP address right after we did the initial configuration of it. So we can configure these things, either autonomous, configure the autonomous APs or the lightweights, the WLCs. The autonomous will be through a web interface like you and I do at home, a web interface to get to the devices. The console port you can use with the CLI or the service port with the GUI. And again, with packet tracer, you're going to have to use the GUI. If you have that option, I wholeheartedly recommend that you use the GUI. This is the one that we were looking at, and let me go back to this. And there are some things, there's lots of stuff that you can't configure on this, but what can we do? You can see they're grayed out. You can see the things that can be configured on it. What goes on here, 192, the management IP address 192.168.1.3, and we got : 128, has the capability to use IPv6, obviously, the system time, the uptime, the protocols, the radios that are up and the radios that are down, all the access points are up, down, up according to this thing. We have 4 ports here, which means that we can have a number of different things connected to it. We got 2 PoE ports here, and if you look at that, PoE, power over Ethernet, Cisco 2500 series wireless. The access points that we have, we can look at those Cisco clean, and this is all the information that's here. The WLANs, that's the monitor that goes on. The WLANs that we created for these things, we have AP groups. This is the default group. If we wanted to create our own groups, we could create groups and we can put machines in those groups and only allow specific SSIDs on that particular group. So you can restrict, control, manage which SSIDs go on which of the wireless LAN controllers. Internal DHCP server. Again, there's a lot of stuff grayed out here, but you can see that those things are there. Inventory. The internal DHCP server, we could configure it if we wanted to. The way this one's set up, the DHCP server is running on the router on a stick. The NTP, CDP, tunneling, IPv6, and again, you can see these things, but you can't change most of them, or you can't do any configuration with them, but you can see the things that would be available. DHCP is one of the things that we could actually, I think we could actually could enable the DHCP server. The wireless lightweight access points that we have, you can click on them, nothing's going to happen here, but these are the access points, the addresses that they have, 1.5 and 1.21, and then how long they've been up. The security that we see on these things, the local EAP, extensible authentication protocol, priority, certificate, access control lists, wireless protection policies or rogue policies that would go on. And again, you can see, poke around, look at the things that can be configured. Many of them, the basic configuration we can do in Packet Tracer. The advanced configuration, obviously, we can't. Commands that are available on here: reset the factory default, set the date and time, set the time zone. Poke around, see what's available on the devices. Clicked on the wrong thing there. Save the configuration. Well, that's probably a good thing to do, right? To save the configuration so that we have it, the copy run start equivalent. We have ping, log out, and refresh. The what can we do, and this shows some of those things. Configure the radius server. Yes, theoretically we can do a radius server, but not in Packet Tracer. There are other things that we can configure. Create a dynamic interface. the interfaces we created. Select Create New. From the WLAN's drop-down menu, enter the configuration parameters, the things that we're going to do, the appropriate security scheme that we're going to use. WPA2 is what we use with WPA2 with a pre-shared key in order to do our security on the interfaces themselves. We can't do that. AAA servers would be it's quality of service. Yes, we can control quality of service. We'll look at quality of service a little bit later this week, and I think I've got a lab that you can do in Packet Tracer so you can see what happens with it. Again, I'll do a demo, have you do it to try to do some reinforcement. Quality of service is when we give priority to certain things. Priority to certain things like for video, so that we don't have emergency phone calls fail. So that the video plays a nice, smooth quality of service, dedicated bandwidth to critical users or applications, controls parameters, affect real-time application, manages the bandwidth, consistent flow, sets and enforces traffic policies, and the selections for it. Let me get back to this thing, and then you can see the selections for it, I think. When we look at it, I think it's back over here in monitor maybe. It allows us to, here it is. Here it is under wireless quality of service. You can see the profiles. We can't change the profiles. Profiles, quality of service map, net flow, different things that are available on it. I know that this, let me see that over here. Rogues. But we can configure quality of service so that certain things get a higher priority, a higher bandwidth. The configurations for those things are going to be platinum, gold, silver, bronze. Oh, I know what it was. It was in the individual configurations. And when we look at it, we go back to the WLANs, and let's look at this guy. Maybe I think it was in here. If we do quality of service, yeah, silver best effort. I can't modify it. It is set for silver. Silver's best effort, which means that nothing gets a priority. So we can configure here in the wireless LANs, we can configure them for quality of service to add priorities one to the other. So platinum is voice. Voice when we have platinum. Gold will be video, our video VLAN. Silver is going to be best effort, and bronze is background. Bronze is going to be everything that's left over. The advanced settings in the advanced tab of this thing in the WLANs, we looked at that a little bit, I think, and this is where in the advanced what could be configured here, and again, not a whole lot, but you will have to enable the Flex Connect and the Flex Connect local authentication. Otherwise, everything's going to get only get an IP address on the management VLAN. Enable the session timeout. Set the security policies. The WLAN issues, and there are just a couple more slides here. Mismatch between the 2.5 and the 5. Maybe in a SOHO, small office, home office network would do that. Connecting to the SSID, if it's not broadcast, it's got to be configured in it, got to be typed in, and the SSIDs are case sensitive. So if you do that, add a network, you've got to add it using the case. Security protocol mismatch, a wireless access point misconfiguration, and as you can probably see, hopefully get to that, some of these things are relatively easy to do. To make those kinds of misconfigurations. General network issues at both ends, different things, and one of the things that I did when I was learning how to do this is I forgot to put the VLANs on the switch, and don't put the VLANs on the switch, then the traffic can't get into the tunnels. The traffic can't get into the tunnels, then I can't get IP addresses. I can't communicate. I can't send the information from the lightweight access points through the switch to the wireless LAN controllers. Basic things, general network issues, configurations, Wi-Fi disconnects. The thing somebody could be trying to attack us to do these things. Troubleshooting, try to connect to the suspect AP with a known good wireless device. Make sure there's enough access points to support all the wireless clients. It's not an unlimited number that can connect. Once you get in the limit, somewhere around 20 to 30, I think, is a good general number. Verify the correct configuration on the wireless access point and the client. Appropriate tools to test the network strength and speed, and you probably have done that. You got an app that you put on your phone. You see how strong it is. Something similar to what I showed this morning. A number of those that are available. I'm just going to tell you what the name of this one is, and it is Wi-Fi Analyzer. That was a tough one to remember. What kind of signal strength are we getting? What kind of am I seeing the SSIDs that I would expect to see? If they don't show up, we need to go look and be sure that they're turned on to be broadcast. If we didn't want them to broadcast, what are the cases? And you probably do want them to broadcast for your users, because odds are you don't want users typing in these names. You can do it. You've got the experience to do it. Wireless security configurations, wired networks physically protect the signals, physically connect the network. You need to physically connect to the network to exploit it. Wireless, we don't really have to do that. It's an RF signal, radio frequency signal. Where does it go? Every place. Who can see it? Everybody that is within the close proximity, within receiving range of it. The protocols, and I think we looked at these a little bit already, a little earlier today. WEP, wired equivalent privacy. The first one, not secure, can be cracked probably under 5 minutes. And there are a lot of YouTube videos if you're interested in seeing how to do that. You will need a Linux machine in order to thing. WPA, Wi-Fi protected access. It was built to replace WEP. It was built as an interim until WPA2 could be developed and put into operation. It uses a 256-bit pre-shared key. Should not be used to secure. WPA2, Wi-Fi protected access 2. Updated and replaced WPA. Personal uses a pre-shared key for authentication. TKIP for encryption. Enterprise uses IEEE 802.1x when we do those things. Your wireless router probably has an enterprise capability. If you have a radius server, and I keep saying radius server, if you have a radius server, you probably can configure it if you want, but you're going to have to be able to get to that radius server. It's going to have to be on all the time. Pre-shared keys are usually what we use on our home. Let's see, the general steps: create the WLAN. On the WLAN, enable WPA2. Configure layer 2 security, enable the policy, select AES or TKIP. Kind of the things that we did and you'll do in the wireless LAN controller when we do those things. Pre-shared key, the text of the pre-shared key, and then save the configuration for the devices. WLAN configuration, again, an image here, the controller. I'd like for you guys to do the lab to actually do controller.